In this video, we're going to discuss constructor and deconstructor methods within Visual Studio.net. Now, we can't start a discussion about this unless we talk about how it used to work in Visual Basic 6.0. Back in Visual Basic 6 days, not too long ago, whenever you created an instance of an object, eventually throughout the course of its life, you'd want to get rid of it. You'd want to free it up so that any memory that was used by it could be returned back to the Windows environment. And so you would do that by setting the object reference equal to nothing. Whenever you set it equal to nothing, you basically reduce the reference counter to that instance of that object by 1. And so whenever that the number of reference counters equals 0, then the Visual Basic runtime would remove that from memory and destroy it. Before it would destroy it, it would call the terminate event so that you could do any last-minute processing or cleanup work. A lot of times people would use that in order to free up any database connections or any limited resource that they might have. So it was very nice. What we call that is deterministic finalization. You knew exactly the moment whenever your objects were cleaned out of memory and when the object's lifetime definitely came to a close. But using that model, there were problems as well. In Visual Basic 6.0, you had problems with object references not being set to nothing, or more importantly, whenever there was some type of a circular reference between two objects, one object would make a reference to the other one would make a reference back, and they would never get cleaned out. And to some extent that was fixed in VB6, but there were still problems across different components. But at any rate, deterministic finalization was a good idea. However, there were some problems inherent with the model. And therefore, one of the things that the .NET Framework and the .NET Runtime give to application developers is this concept of garbage collection, that you don't have to worry about those types of things, that the .NET Framework will manage your memory for you and thereby manage lots of services, not just memory, and that's why your applications are called managed applications. But at any rate, the ability for it to clean up the garbage for you, or these reference counters, basically introduced a new idea within Visual Basic, that you no longer absolutely knew when your object was taken out of memory. And this is referred to as indeterministic finalization. And therefore, once you turn your reference to an object over to the .NET Framework, or rather the .NET Runtime, it made a decision as to when it was actually going to take that object out of memory. It might be instantly, it might be 10 seconds or a minute from now, or whenever the application is closed. But when it needs more memory, it'll go through and see what it can clean up. And it's beautiful in some respects because you don't really have to worry to some degree about setting your objects equal to nothing. If you don't do it, if you forget to, it's not going to really penalize you for that. And so when they go out of scope, whenever the garbage collector gets around to it, it'll clean it up, and there won't be any. It'll cut down on memory leaks. I won't say there won't be any. We don't know that yet. But at any rate, it's a really clean model. The problem is that we don't know exactly when the application dies. So I've gone into this huge, long explanation. Sorry, there's a lot of background to this topic. So what we're going to do now is kind of get an idea of the lifetime of an object by talking about the code that can be called when an object is actually instantiated, or when an instance of an object is created, and then also whenever it goes out of. So what I've done to illustrate this is to create a little application that has two parts to it. There's a form that simply has a button on it, and there's some code behind that button. We'll show you that in a moment. And then there's a class that we've created called Automobile. And what we've done is simply created the constructor, which is new, and then two other methods. But let's start with the constructor. Basically, within Visual Basic, you can have what's called a constructor. It's the same thing as the initialize from Visual Basic 6.0. The difference is that it has to be called new, within Visual Basic.NET that's different than it is the way that it is in C#. And so when a new instance of your object's created, it's going to call the code within this public sub-new. In this case, we're just going to pop open a message box to show that new was called. And then what we're going to do within the code, we supply a protected override sub finalize. Now this is your way around, to some degree, the finalization, where once the object is about to be garbage collected, it will fire any of the code that you have within here. So, but this may not happen right away. So you might set your object reference equal to nothing, but this may not happen for a minute, 2 minutes, or whatever time it needs until it can clean out the garbage. So what we're going to do is, whenever that event does fire off, we're going to shoot up a message box that says finalize calls. Now, as kind of a convention that some VB developers are using, they create another public method called dispose. There's nothing magic about the word dispose. It's just something that Visual Basic developers in general have done. What you can do in here is get rid of any connections to databases, just basically what you would have done in the terminate event in VB6. You could do it here, and at least there would be some form of knowing that the code is cleaned up when you want it to be cleaned up. So it's just basically a method that you'll create. You can call it anything you want, but right before you set your object reference equal to nothing, you would call this dispose method, and it would clean up any loose ends within your application. So in this case, what we've done here is dispose called will be displayed in the message box. So now we're going to use this automobile class within our application. I've created a very simple web forms app, and basically inside of its button one click event, I create a new instance of the automobile object and call it myAuto, and we call it the new method, the constructor for automobile. Then let's say we do some stuff in here that's not really important, like call its other properties and methods if we actually had some, and then we'll finally call the dispose, and then we'll set the object reference equal to nothing. Just remember, in Visual Basic.NET, you don't need the set statement. And so we're going to set the reference equal to nothing, and then we're going to watch how long it takes until something actually happens with the garbage collection, until the finalize event is finally called within our automobile class. So what we'll do, we'll go ahead and save this, and we'll make a build of our little application we've created. And then I'm going to shut that down and hit run. And after a moment or two, our WinForm pops open. And what I'm going to do is click button 1, and notice that our first message box arrives, new is called. Okay. Now once I click OK, there's going to be another message box pop up immediately. If this had been a real application, you'd probably have some processing in here where you actually called the object to do things for you, processing within your application. But you'll notice I clicked OK, and now the dispose method is automatically called. So 2 out of the 3 message boxes have appeared. So I'm going to select the OK button, and I'm going to wait and wait and wait for the finalize method, which never really happens. Now, again, if the garbage collection within the .NET runtime really determined that it needed to clean up some memory, we might see that message pretty quick. But I've got a lot of memory on my system, I'm assuming is the case, and that there's no desperate need for more memory, so it never makes really the effort to clean it up. Because garbage collection is actually a processor-intensive operation, therefore they don't just do it willy-nilly. So what we can do to invoke the garbage collection is actually close our application. And when we do, we'll notice that last box is actually message box pops up, and it says finalize called, and now we're out of our application. Notice that I didn't click it, it just kind of happened on its own. So I just want to make one last note before we conclude. Basically, we talked very briefly about the constructor. The constructor is important because whenever you want to initialize any values, whether they're fields or property values within your class, you can do it from here. You can set up any database connections from here. Anything you need to do to make the automobile class as usable as possible to its potential users, you should try to do here. But also what you can do is override the constructor so that you give the consumer of this class several options of constructors. You can have one constructor that, as we see here, takes no parameters whatsoever. We can add 2, 3, 5 more constructors that have a various number of overloaded constructors in there, and any number of parameters inside the overloaded constructor. And we'll show you how to do that in a future video that'll be available sometime soon. So I hope that this was very helpful. It helps you understand constructors and destructor methods, which essentially these combine together to create a destructor type of method. I don't know if you'd officially call one or the other a destructor. But at any rate, more importantly than that, we talked about the lifetime of your application, or specifically of your components, and maybe a convention that you can use to get around indeterministic finalization if you've relied on that in the past. So I hope this video was helpful to you.